Assalamu alaikum. Now we will start with topic 6.3, which is Doppler effect. So here I want you to pay attention to these notes. For example, direct motion, the wave fronts, and if the object is moving, the moving will be towards the compression area, as you can see here. So the object is moving towards the left. Closer the wave fronts means higher frequency. Spread wavefronts means lower frequency. يعني this one is moving towards A. Information 2, if we have closer wavefronts, this means high frequency. Note 3, spread wavefronts means that low frequency. Okay, and Doppler effect can be applied to sound, light, or any type of wave. Okay, these circles we call them wave fronts. So let's check question 35, part A. The diagram represents wave around the sound source that is moving with a constant velocity through air. The source produces waves at constant frequency. The source is moving towards what? The source is moving towards point A. Compared with the frequency of the waves observed at C, the frequency of the waves observed at A is greater than observed at C because we have a tighter or compressed wavefronts. For question 6.36, subtopic 6.33, here I want you to pay attention to these formulas. If the observer is moving towards the source, f prime equal fs v plus v source over v, and if it's moving away, it's f prime equal fs v minus vs over v. Okay, so let's check question 36. A stationary siren means the source of the sound is stationary, it's fixed, ما بتحرك, emits a sound frequency of 800. So if the source, frequency of the source 800, the speed of the sound, which is what? 340. A cyclist, which is the observer, is moving towards the siren, towards the source. معطيني Vs equal 9. Calculate the frequency. Use f prime fs equal 800. Since it's moving towards, it's v, which is 340 plus 9 over 340. Using the calculator, it's 821 Hertz. A stationary siren, we have a siren stationary, which is the source is not moving. We have fs equal 800. We have the speed v equal 340. The passenger of a car moving away, the observer is moving away, we have the hearing frequency 750. Again, he needs f, it's 800. This time it's what? It's he needs what? Calculate the speed of the car, so he needs v, and he f prime, this one is f prime. Okay, so let's rearrange. So this one is f prime. Okay, so f prime 750 equal 800 multiplied by 340 minus v over 340. Using shift calculate, it's 25 meters per second. Okay, for question 38, note that this information, if the source is approaching f prime equal fs, but flip the formula, v minus vs. As moving away, it will be plus. Okay, so let's go back to the question. We have a train moving, so the source is moving, which is v, the source, equal 30 meters per second. and produces a sound, which is the source, 150 Hertz. What's the frequency heard by the observer? So it needs f prime as the train approaches, and we have v, which is equal to 343. So apply f prime equals 150 times v, which is 343 over 343 minus 30. Using the calculator, it's 164 Hertz. What happens to the pitch of the sound passing by the ambient? It's moving towards you. The moving towards you, the pitch or the حدة الصوت راح تزيد. Okay, and that's it for this topic. Thank you.